Hi guys, welcome to the next chapter. We are starting the chapter on atoms and molecules. So we learned in the last class that matter can be three types, like solid, liquid, and gas. But right from like the early days, human beings are very imaginative. So they imagine what would happen if you have some kind of matter and you started to break it into smaller pieces. So they started to think what would happen when you keep on doing this process, like keep on getting to smaller and smaller and smaller pieces. So they imagine that if you have a carbon, so if you have say diamond or coal or graphite, something like that. So when you start to like break down that thing into smaller and smaller pieces, people imagine that they would come to a particle, for lack of an appropriate word now, they would come to a smallest particle and that would be the atom, right? So that's what they imagine. The same goes for like iron, so like an iron bar. Like you keep on making it smaller and smaller and smaller, the ultimate, like finally what you get is an iron atom. They also thought the same for water. So they thought that, okay, you have water, you keep on breaking it into smaller and smaller, but you don't get a water atom because water is not an element, right? So carbon is an element, iron is an element. Water is a compound. It's made up of different elements, right? Water is made up of H2O, so hydrogen and oxygen. But if you take hydrogen gas and continuously break, you will get a hydrogen atom finally, right? But oxygen, you'll get an oxygen atom finally. But for water, it's not the case. Why? Because it's a compound. And we'll study about compounds later. But for all practical purposes, here we have to understand that when you have an element, you break down and you get an atom at the end. So how many elements do we have right now in our universe? Scientists have reported 118 elements till date. And the last one has a weird name, organocin or something like that. Okay, so there are 118 elements, and all these elements are arranged in a very strategic and very intelligent way called the periodic table, right? So we could also have arranged all the elements as a list. So we would have given a long list, but no. What we chose to do, the scientists the chemists have come up with a very intelligent way of putting down all the elements that we have in a form of a table called the periodic table. We will study why it's called the periodic table and not the elemental table. Why? Periodic means recurring. So there is some of these things. The periodic word is because the properties of these elements, when arranged in a very intelligent way, the properties are periodic. That's why we have the name periodic table, and that's why we don't have a list, we have a table, okay? So, like we have the elements, we have the hydrogen element, we have the oxygen, the nitrogen, carbon, and so on and so forth. We have 118 of them, okay? So, everything in this universe is made up of these 118 elements, right? So there can be nothing other than these. There might be a few that we haven't discovered yet, but most of the things in this universe are made up of these 118 elements. For an analogous concept, like the English, the language is made up of 26 alphabets, right? So there are just 26 alphabets, and everything that is there in English language has come from a combination of those 26. Like everything imaginable is coming from only those 26 alphabets. All the stories and all the novels and all the poems and everything are those. And the same goes for the elements, right? Everything in this universe is made up of these elements, right? So now we know what an atom is. Like you keep on like going to the smallest and you get an atom. Now let's study what's there inside an atom. All right, so let's study what's there inside an atom, right? So what is the structure of the atom? We are just considering here the basics. So what we are trying to see and learn is the subatomic particles. What is the atom made up of? So when atom was first discovered, thought about and discovered by John Dalton, he used the word atomos for atom, like the short form of atomos. And atomos means indivisible or indestructible. But to his dismay, atom is made up of different particles, which is called the subatomic particles, right? So what is the atom actually made up of? It's made up of primarily two things: the nucleus, which is at the center, and the electrons, which surrounds them as a cloud. Now, to understand this concept, look at this. This small ball, right? So let's imagine there is a tiny speck of dust at the center, or it's a small ball at the center of this big ball, right? So that small ball, which is there at the center of this ball, the bigger one, is the atom, and the whites and the space that this white thing it takes up the space, that is the electron cloud. What is an electron cloud exactly? Now, previously we had a model of the planetary model of the atomic structure, where it was imagined that you had a nucleus in the center and electrons used to travel in orbits around the central nucleus. But now we know that this is a flawed model. Why is it flawed? Why is it wrong? We'll study that in subsequent lectures, but for the purpose of this lecture, we have to understand that this is not the right representation of an atom. The right representation is something like this, in which you have the central nucleus and it is surrounded by an electron cloud, right? So what's an electron cloud? So for example, let's say you have a really good camera and you're able to see the nucleus in here and the electron in here. So you take an image of that atom, right? So the electron might be somewhere here at one instant in that image. The next instant it goes to somewhere here, and you take another snap, and you keep on taking different snaps, and then you superimpose all these images and then see it together. You will see that the electron forms this cloud surrounding this nucleus. So that is electron cloud. It doesn't mean that that space is filled with electrons. It's not like that. It's the electron cloud. The meaning of electron cloud is that the electron is present somewhere in this region. Electron or electrons, multiples, like there can be many electrons, and these shapes can vary. We'll study about the different shapes of electron clouds in a subsequent lecture, but for the purposes of this class, we have to understand that, okay, these shapes can be different. For simplicity, let's assume that it's spherical in shape, the electron cloud, so that there's a nucleus and there's this electron. So we have the electrons in this nucleus, in this electron cloud. Now, the electrons have a negative charge, right? What is the value of that charge? Now, what is the SI unit of charge is Coulomb, right? The SI unit, like the SI unit of length is meters, the SI unit of charge is Coulomb. Now, what is the exact amount of charge that is there in one electron? It is negative 1.602 into 10 to the power minus 19 Coulomb. Now, if you do not know what 10 to the power minus 19 means, it is a scientific way of representing a very small number. So, for example, if I write 10 to the power minus 1, I just simply mean 0.1. If I write 10 to the power minus 3, I mean 0.001, okay? So this means for 10 to the power minus 19, this means you have 18 zeros and then a 1. That is 10 to the power minus 19. That's the value of 10 to the power minus 19. So what is the charge in an electron? It's that. There's also one concept that there are two types of charge, a positive charge and a negative charge. It does not mean that the positive charge is higher in magnitude than the negative charge. Like for example, in a number line, a plus 1 is a higher number than minus 1. This is not the case in the case of the electrons. It is just there are two types of charges, and for simplicity's sake, we have just assumed that one type of charge, we call it a positive charge. The other type of charge, we call it a negative charge. We could have called it anything, right? We could have called it a blue charge and a red charge, right? But okay, that would be lame. But in here, a negative charge is just signifying the type of charge. It doesn't mean a negative 1 coulomb charge is less powerful, less strength, less in magnitude that plus 1 coulomb charge. That only means that the type of the charge is different. Okay. Also, the charge on an electron is the least possible, is the smallest charge possible. So that is called the elementary charge unit. Like if you try and understand with an analogous concept, the denominations in America are like dollars. So what is the smallest value of denomination that you can have? It's 1 cent, right? So you cannot have anything that is less than 1 cent. That is the least amount, that is the elementary monetary unit that is there in America, like a cent. So all other charges will be some integer multiple of this elementary charge. You can have you can have this 2 times, like 2 times this can be a charge, 3 times that can be. So you can have some integer number times the basic elementary charge unit, and those are the only charges possible in nature, right? You cannot have 3.5 cents, right? You cannot, because there is no 0.5. So you can have 1 cent, 3 cents, 4 cents, but you cannot have 3.5 cents. So it's the same concept in here. So you cannot have 0.5 of this. So this is the least charge possible. For simplicity's sake, we say that the charge on the electron is -1. But please keep in mind that that does not mean that the charge on the electron is -1 coulomb. The charge on the electron is this. For simplicity's sake, we say it has a -1 charge. Okay? So, if someone asks you what's the charge on 5 electrons, in coulomb, you cannot say it's -5. You have to say -5 times this number is the charge of 5 electrons. Okay? Cool. Moving on, what is the mass of the electrons? Like you see, the mass of the electrons is also a very small number. 9.11 into 10 to the -28 grams is like really, really, really lightweight. Right? Alright. Moving on to the heavyweights. The heavyweights are what we have in the nucleus. The nucleus is made up of 2 things, the neutrons and the protons. So, the protons is a P, is a positive charge. What's the magnitude of the charge? It's the exact same magnitude as this. Only the difference is the sign of the charge. It's a different type of charge, it's the positive charge. The magnitude is exactly the same. Okay? Plus 1.602 into 10 to the -19 coulomb. Okay? That doesn't mean that this is higher than this, it is just the side, is just the type of the charge. Now, how heavy is a proton than the electron? It is almost 2,000 times heavier than the electron. It's like very, very, very heavy as compared to the mass of the electrons. How do you remember this? I mean, 18 times 2 is 36. It's kind of like, you can remember it like that, right? 18, 36 times. So for all practical purposes, you can say it's about 2,000 times heavier than the electron. So, proton is heavy, like quite heavy than that of the electrons. What about neutrons? Neutron, N, so no charge, right? But there is no charge on a neutron, which is good. So you have a negative charge, you have a positive charge, and there's no charge, right? But it has mass. It has mass almost as equal as the proton, right? It's almost same, but since you're here and studying from us, you should know that the mass of the neutron is slightly heavier than the mass of the proton. It's like 0.14% higher than the mass of the mass of the proton, which also makes neutrons heavier than electrons by about 2,000, and even heavier than the protons by about this number. For practical purposes, we'll say the mass is the same, but we should know, slightly heavier. Also, another thing is the size of the atom is really small. But what is this is not a shocker. But what is a shocker, at least for me it was, that the nucleus is like really, really, really small, even as compared to the size of the atom. So if you have a sphere which is about 1 meter in radius, a tiny speck of dust inside that sphere will represent the nucleus. So if you have a sphere and this sphere represents the sphere of radius 1 meter represents an atom, a tiny speck of dust inside that big sphere will represent the nucleus, right? So it's extremely small. For a general idea, the size of an atom is about 10 to the power minus 10 meters, the radius. It's about 1 angstrom, right? Like 10 to the power minus 10 meters is like 1 angstrom. But the nucleus is about 10 to the power minus 15 meters. So it's like a 10 to the power 5 magnitudes is about 100,000 times smaller than the size of the atom. So it's like extremely small, okay? So now that we know what's inside the atom, now let's study about what are the different identification numbers associated with the atoms.